Every year, equipment downtime costs the automotive and electronics industries in the Asia-Pacific region a staggering $28.56 billion. It's not just about the money. It's the ripple effect of stalled production lines and missed opportunities. Our system addresses this costly challenge head-on. We know that manufacturers are struggling to take new technologies such as predictive maintenance beyond proof of concept and realizing the full potential value of generative AI. That's why we are introducing GenAI Predictive Maintenance, a system that helps manufacturers creating quantified business value, increase flexibility, and reduce cost. We believe the recipe to success is to combine three perspectives throughout the process: technology, operation, and business, and to work collaboratively together as a team every step of the way. Central to our approach is an AI-driven system, architected to turn data into foresight. It starts with our SCADA interface, gathering data in real time from a network of smart sensors. This data is then orchestrated through a suite of cloud technologies, including functions for processing, PubSub for messaging, Dataflow for analytics, and BigQuery for warehousing. Here's where our GenAI becomes pivotal, generating synthetic future data benchmarked against XGBoost models to extrapolate potential failures with remarkable precision. AlloyDB's robust processing and Gemini AI and Vertex AI's capabilities then synthesize this information, offering not just a glimpse but a clear vision of the future. In the heart of our system lies the root cause analysis feature, an analytical powerhouse that does more than pinpoint failures. It dissects them. By evaluating historical and real-time data, our system doesn't just predict if a failure will happen, it determines why, categorizing each potential issue with astonishing accuracy. Take, for example, the turbine flow rate, a critical component with a 61% chance of being the next downtime culprit. Our system anticipates this event before it unfolds, all the way down to the predicted date and remaining useful life percentage. Our RWL graph shows not only a visual forecast of when a component might fail, but when its efficiency starts to decline, giving maintenance teams a clear timeline for action. Let's look at the graph. The line represents the health of a component over time, with green indicating low risk, yellow for medium, and red signaling high risk of failure. This allows us to predict, with an unprecedented 70% reduction in downtime, what component will fail and why, shifting from reactive to truly prescriptive maintenance.